Okay, so I have been playing around with some AI stuff, and I thought that I would share something with you guys. I think the future of education is changing on a daily basis. This is NotebookLM, which is a notebook language model. It's essentially like an LLM, large language model, but based upon what you feed it only. So, for example, in this one, I only fed it the section from our textbook at CRC covering mathematical induction for Math 372 and 384 and 375 and 370 and whatever other pre-calculus course we have. I also included some external stuff, basically by clicking add here. And actually, I think that one I just went to, discover sources. And I typed in here, suggest some extra sources that would cover mathematical induction. And then it suggested some, most of which I didn't like, but I kept some there just so you could see it. So these are the sources it will pull its information from. I can actually turn off sources or turn only certain ones on, whatever. And you can add in videos, you can add in audio, you can add in PDFs and doc files. All right. You can see that it summarizes initially what you've put in. And if I click refresh there, it'll just take a moment to refresh all that. It summarizes that. Also, I could put in an audio overview. I'm going to put in a mind map here. And at the bottom, it has suggestions. Now, imagine you're a student, and this is free for students. And so what you do is you paste in maybe the textbook section that you're in and some sources, maybe a Khan Academy video, or maybe videos that your professor has given you, right? Videos of me, if it were my students, whatnot. And then you might ask this very first question, which is right here. You could see at the bottom. Very first question is, what are the fundamental components and steps required for proving mathematical statements using induction? So if I click on that, it will then generate only from this group of material a response to that question. So it's sort of like, in a way, taking notes and summarizing in the background. Now, there are many possibilities here. And I'm not saying they're good possibilities. I'm just saying they're possibilities. Oh, by the way, you can see on the screen right now, clearly state the base case, right? And it cites sources throughout. Okay, so I could actually follow these sources if I want to, and then formulate the inductive hypothesis, and then perform the induction step and state the conclusion. And you can save these. So a student who likes this explanation can save that note off to the side. It will save it and label it accordingly. And then maybe they have other questions. This is kind of very dumbed down. It leads them, right? Well, what is the inductive hypothesis? Right. So it will then respond to that. While it's building that, though, let me go ahead and click on this mind map, and then I'm going to tell you the implications of this. So if I click on the mind map, here we are. It developed this all on its own. I did nothing other than fed it the textbook and a couple extra websites. So there we go. We have definitions that'll lead you to a method of mathematical proof statements for all natural numbers, yada, yada, yada. The process, principle of mathematical induction. So I'm just going to click on that to showcase what this looks like, because I'm very curious here. You can see that it actually goes through based on the sources in our conversation, yada, yada, yada. It goes through and does that. I'm going to scroll up a little bit here. I think it was still generating in the background. And just see... we already did all that. If I want to save that, I would, but I don't want to, and I don't care to. But you can go back to, again, the mind map, writing induction proofs, right? Just a lot of, this is pretty insane. A lot of the, you have to be very careful with the information you provide it, right? You have to vet that information. But once you vet that information and you provide that information or the vetted information to the student, they could do this. And you could build these for your classes. Why you would possibly want to, this is just a hypothesis right now, but why you might want to provide something like this for your students is it's new. And it shows that you're trying to beat them to the punch in a way and saying, listen, I get it. You're going to search AI for stuff. Let's constrain it to just the information that I'm allowing you to have. And then you could search my information. And here is the creepiest part. I'm going to play a little something.
You know, in math, sometimes you see patterns, right? Like they seem to work for the first few numbers you try.
Oh, definitely. Like adding odd numbers 1 plus 3 is 4, 1 plus 3 plus 5 is 9.
Yeah.
Looks like perfect squares.
Exactly. But how do you go from it looks like it works to knowing like for sure that it works for all numbers forever?
Well, that's a big question. And one really powerful answer is a technique called proof by mathematical induction.
All right, I'm going to pause it right there. So that is all AI, voices and everything. The entire script, all of that is generated just from the sources that I put here. And it's having an audio overview of just an introduction to principal mathematical induction. And that is actually how I posited this. I don't know if it's going to show that. Nope. Get off that there. Okay, so I can't show you the prompt that I put in there, but it's literally just a couple sentences saying, please do an overview of the principle of mathematical induction using this. It'll only use these sources anyway, so I don't have to say using these sources. But I did say focus on the concept of it being a domino proof, that the base case is knocking over the first domino and so on and so forth. And I think it does that.
Mathematical induction. Okay. And that's what we're diving into today.
Yep. It's this really clever way to prove statements that apply to all natural numbers, 1, 2, 3, and onwards.
Without checking every single one because, well, you can't.
Precisely. You can't check infinitely many cases. So induction gives us a structure almost like setting up a chain reaction.
A chain reaction. Okay, I like that. So maybe like dominoes. Is that the idea we're exploring?
That's the perfect analogy, I think. That's the mission for this deep dive. Understanding induction by picturing this infinite line of dominoes.
Okay.
So that idea was not in the original iteration of this because really I didn't force it to use the concept of a domino. The other cool thing here is you see these other kind of buttons, they are buttons down here. Study guide. So if I click on that, it'll generate a study guide. I'm just curious about the FAQ and the briefing doc. So I'm just going to let it generate those in the background. While it generates those, I am also going to go to the interactive beta mode here. I really want to showcase that because I haven't been able to play with it. Actually, before I get there though, let's go ahead and see what these are. This is a briefing document. This is a study guide. Let's go to the study guide. Study guide, proof by mathematical induction. So it's basically a summary, just a study guide that students can use, and it has quizzes. Answer the following questions in 2 to 3 sentences each. What's the purpose? What are the key differences? So I don't really cover weak and strong induction, namely in my courses. That was just from one of the other sources over here. I just thought it was kind of interesting, so I wanted to see it. And then quiz answer key and essay format questions, and then a glossary. This is sickeningly amazing. I mean, it is just amazing. And then I can convert that to a source so that it becomes one of the sources here, and I can turn off other sources, is what I'm assuming is the case. I'm going to go ahead and hop back to the studio really quickly. And let's see, now I'm going to go ahead and go to the interactive mode beta. Now, the beta mode here, this is the first time I'm playing with it. I haven't played with this before, so forgive me while I just get acclimated. So I think what I'm going to do is I'm just going to try to regenerate very quickly the audio. This time I could click just generate. It would do an overview of the entire section. But again, I might want to go and customize that and say, let's go through an example. So, and I guess while it's going through that, I want to share a couple other things. You can get analytics if you've shared this notebook with people. Basically means you can share this notebook with people. Down here, you can notify people, you can add people in groups and whatnot. And my guess is it's only available. Well, no, it probably is available to anybody just to view the notebook. You can have a welcome note. So if it's for your class, you could have a welcome note, welcome to my class, that type of thing. You can give them full access to the notebook, which mainly says that they can chat with each other, chat with the notebook itself, and view the resources or the sources that you have off to the left there, and view any notes you have on the right-hand side. If you don't want them to do that, you can have it chat only. And I haven't noticed the preview, so let's preview and see what it looks like. Just like that, not much, right? What is PMI? Let's just see what that says. Remember, it's only pulling from the sources that I gave it. This is actually, in my opinion, the ideal when it comes to controlling what AI presents to students. You have a lot more control in this case. Again, if it's only as good as the sources you provide, but it's only pulling from those sources. So very, very nice. All right, going back here, then you copy the link and send it to your class or something like that. I'm just going to go ahead and close that out because we now have our brand new principal mathematical induction going through an example. Let's see if I can get this to work.
That's really interesting to hear about those AI hosts. It sounds like the technology is still developing, but the ability to ask for more detail is definitely a step in the right direction. It highlights how important clear explanations are, which is what we're aiming for with mathematical induction today.
Absolutely. And you touched on something key there. Even if an AI can re-explain, understanding the why behind a proof, the robust logic, that's where the real learning happens. And that's what induction helps us do. It's more than just checking a few cases.
Precisely. It's about establishing a chain of truth. Think of it like this. We want to show something is true for all natural numbers. How do we tackle that infinity?
Right. It feels overwhelming to even think about checking every single number.
So this is something that I've noticed with all of the summary things like this, is that it's a lot of nothing in a way. So they kind of banter back and forth. They keep repeating the same things. And so maybe that's good for students. I'm not 100% sure. I'm going to try to bust in on this conversation.
Exactly. So induction gives us a clever workaround. We break it down into two essential parts.
2 parts. Okay, what are they?
The first part is all about getting started. It's what we call the base case.
Base case. Sounds foundational.
It is. It's like making...
Oh yeah, let's hear it.
Aren't there 3 cases or 3 steps to the proofs by mathematical induction?
That's a really insightful question. It's true that sometimes when you look at more complex proofs by induction, especially in areas like inequalities, you might see a need to check more than just the very first base case.
What's fascinating here is that while the core structure involves a single base case and the inductive step, the base case itself might require verifying the statement for a few initial values to get the chain reaction started properly, especially when dealing with inequalities or sequences defined by multiple preceding terms.
Okay, let's unpack this a little. So the fundamental...
All right. And if I didn't edit this video, that took a lot of tries to get their response. So it's still early days on at least that feature, but come on. Early days means next week it's fixed, that type of thing. The most important part of this is on a per section basis, or even a per chapter basis, to have this as your kind of Discord, maybe, is a really interesting, I'm not going to say great, I'm going to say it's an interesting idea, but it does possibly change the face of what education is. This makes the educator more the facilitator, providing avenues through which students can gain knowledge. And then in the classroom, you could then use that time to sharpen those skills and provide practice, even though, to be very honest, I'm a firm believer that students should practice outside of the classroom. But here is a great tool possibly for the future of our students. Anyway, I thought you'd be interested in that. You could do this for a lot of things. Anyway, very, very interesting stuff. I thought you guys would be interested. Have a good day.